this is an introduction to section 4.2, and 4.2 is graphing quadratic functions in Vertex and Intercept form. And 4.1, you'll probably recall that you did standard form, so we're going to do two different forms of quadratic equations. And probably in Algebra 1 you didn't cover these two forms, so it's kind of nice to have a handful of forms and options, and each of them kind of utilize different pieces of the graph that are important. So first I'm going to focus on vertex form, and the form itself should actually look very familiar to you. So take a second, pause the video, and jot this down. It's very important that you know the form. I'm not going to have this for you on a test, so you do need to have it memorized. So y equals a, you should recognize a, times the quantity x minus h squared plus k. You should also recognize h and k from when you did absolute value functions, and the good news is h and k do the same thing with a quadratic as they do with an absolute value function. So this graph is just a regular quadratic graph, but it's translated h units horizontally and k units vertically. So you probably recall that, but if not, remind yourself. So h will shift you horizontally and k will shift you vertically. Now the other thing you need to remind yourself, sometimes I call h the tricky h. So in other words, it's always the opposite of what you think. So I'm just going to remind you that. So if it says plus 6, you actually go to the left 6 and vice versa. So if you think about, if you have a parabola that's centered at the origin, but then suddenly you take an h and a k, let's say you shift to the right 2, and let's say down 3. So if you shift to the right 2 and down 3, suddenly your vertex is here. So you have the same width and whatnot, but it's shifted horizontally and vertically. So basically that vertex is going to be your h and your k, because that's where you're shifting. So then your axis of symmetry, of course, will always go through the x coordinate of your vertex, so that's going to be x equals whatever h is. And then a does the same as it did in standard form, so that's good news. That will never change. So if your graph opens up, your a value is positive, and if your graph is opening down, your a value is negative. So putting this all together just to make sure that it works, or I'm sorry, that it makes sense to you, if you note this equation I have here, y equals negative 3 times the quantity x minus 1 squared plus 4. So your a is negative 3, your h is 1, and your k is positive 4. So that means from your origin, I would shift to the right 1 up 4, and that's going to be my vertex. And then of course you know a works like or is like your pattern of change, so you know you're going to have some parabola opening down, and I won't complete this because other videos will work through this. But a real easy form, in fact my favorite form because it's so easy to utilize. The other form that you're going to be introduced to is intercept form, and again you want to know this, so take a second, pause the video, and jot this down. So y equals a times the quantity x minus p times x minus q. And this form, a is the same, so again, actually I'm going to fill that in. So the graph will open up if a is positive, and it will open down if a is negative, so that will not change. However, the p and the q are actually your x-intercepts. So now the x-intercepts are going to be at p and q. And just like h in vertex form, notice that it's minus p and minus q. So if it's minus 4, it's actually going to have an x-intercept at positive 4. So they are like the tricky h, they're always opposite signs. So if you think about this, actually I'm going to come down here. My x-intercepts are going to be at, if I solve this, and really essentially it's finding some solutions. So if I take that x minus 2 and set it equal to 0, I know that an x-intercept is going to be at positive 2. If I take the other quantity x plus 4 and set it equal to 0, I know that the other x-intercept will be at negative 4. So let's say this is -4 and this is 2. My A is positive, so I know it's going to open up. So I know somewhat my, sorry, that's lopsided, my parabola will be opening up and has to cross through these two x-intercepts. Well, because a parabola is symmetric, what do you know about the axis of symmetry? You know it's halfway in between. So the axis of symmetry is halfway in between your P and Q values, or your two x-intercepts. So in my example here, my axis of symmetry is going to be x equals -2 because that's halfway in between. If it's not so easy, like let's say this is -4.827 and this is 2.64989, the halfway in between that, of course, would be the sum of P plus Q cut in half. So you can always, you know, -4 plus 2 is -2. Cut in half would be -1. Oh, wow. If I could do basic math, that might help. Sorry, this is -1 is the midpoint there. That's also going to be the, for your vertex, whatever your axis of symmetry is, you know, is also the x-coordinate of your vertex. Well, then how do you find the y-coordinate of your vertex? Well, once you know x, just like standard form, you can plug it in for the x's here and solve for y. And I will walk through that in another equation. Lastly, and you're probably familiar with maximum and minimum values, so you're going to now have them in a different form, but please remind yourself that maximum values or minimum values are the y coordinates of your vertex, not the actual full xy coordinate. So looking at the first one, do you recognize that that's in vertex form? And if not, notice the quantity squared. That should give away that that's vertex form. So you know that your vertex is HK, tricky H, right? So -2 and 3. And the maximum, or I'm sorry, and A is negative, so I know that it's opening down so that I have a maximum point, right? So my maximum value is y equals 3. The other one over here recognizes an intercept form, and really the biggest thing about this is that you have quantities, but neither of them are squared, so it's definitely intercept form. And my x-intercepts are going to be at -1, remember they're always opposite, and then +4. And A is positive, so it's going to be opening up. So it's going to be a parabola looking something like this. Halfway in between -1 and 4 is 1.5, because 4 plus -1 is 3, and 3 cut in half is 1.5. So let's just say that 1.5 is right here. And that's the x-coordinate of my vertex. And then to find y, I'm going to plug in 1.5 for my x and do some math here. And I do this in another video, and I'll do it a little bit slower. But anyway, you can plug that into your calculator to get the y-coordinate, which is -12.5. And that is because I have a parabola opening up, my minimum value. So I had a maximum value and a minimum value.